Welcome to this series of videos from Nidec drives, where we'll show you how to use our drives and motors with Beckhoff TwinCAT PLCs. I'm Scott Meredith Jones, Principal Automation Engineer at Control Techniques R&D. In the following videos, I'm going to introduce some of the drive changes, PC software updates, and TwinCAT motion interface libraries that we have been working on. These developments make using a Nidec drives product and a Beckhoff device together much easier. First few videos in the series focus on how to get the drive going as an out-of-box startup, which include TwinCAT project setup so that you can get ADS comms running, so that means you'll be able to get communications between the Control Techniques Connect software and the PLC or IPC that you're using in the TwinCAT environment. Configuring the drive using Control Techniques Connect software, scaling units and limits for an NC axis in the TwinCAT environment, basic motion using PLC open on an NC axis, so we're talking about function blocks like MC power, MC jog, MC reset, and then full axis interfaces for speed, positioning, or EGB or gearing applications. Later on in the series we have some much shorter videos that show how to do certain common automation tasks, like how to map PDOs to drive parameters, how to use SDOs to read or write values from the drive, how to use startup lists to configure drive parameters, how to set up a virtual master as part of an electronic line chat system, so that's one where several drives follow a common calculated reference within the TwinCAT environment. All of the videos in the series are backed up by a manual, so we've got step-by-step instructions with screenshots, the full works, any calculations, so there is no need to make notes. A link to the manual and any other useful materials is in the description for this video. In the videos, I'll be using the following hardware. So I'm going to be using a Unidrive M700 fitted with an SI EtherCAT module, a Control Techniques dynamic servo motor, a Windows PC, a Beckhoff C6025 series IPC loaded with the TwinCAT runtime. The drive itself has a safe torque off switch so it can enable and disable the drive, and then a load of Cat6 Ethernet cables to make the Ethernet connection to the PLC and then make the EtherCAT connection from the PLC to the drive. So in terms of hardware connectivity, this is kind of what it looks like. So as you can see, we have, just turn on my laser pen, got laptop, got a connection over Ethernet to LAN 1 of the C6025 IPC, and then EtherCAT out from the IPC into the EtherCAT module, which is then plugged into this drive and gives it EtherCAT capability. Connected to that drive is a Control Techniques dynamic servo motor with a pulley on the end to simulate load dynamics. It is assumed that the PC has the latest version of Connect installed. The PC has a minimum of Beckhoff TwinCAT TCXAE shell build 4024.65 installed, and if you're interested in using EOE, which is Ethernet over EtherCAT, you must have administrator rights on the PC to be able to configure the static routes that are required for that particular set of communications. However, if you're not doing anything with the EOE, you don't need this last point. It's also assumed that you've got some kind of basic PLC programming experience, some understanding of PLC open or TwinCAT NC axis, basic knowledge of the TwinCAT programming environment, so you know how to compile, that kind of thing, and basic understanding of motion system components like drives, IPCs, PLCs, encoders and motors. All of these things are kind of beyond the scope of this particular set of videos to teach, but they will be mentioned in passing as we're kind of configuring the basic system setup. So, with all that said, join me in the next video where we'll set up the PLC ready to allow AOE and ADS comms to work so that Connect can talk with the drives over the EtherCAT network. Let's get into it.